Welcome to doing Hardy-Weinberg problems with Mr. Nutran. So now, the key things you guys need to remember with the Hardy-Weinberg is what all of these variables mean. That is the challenge. So let's list them out here. This is the dominant allele frequency, and default Q would be the recessive allele frequency. Then there's the equation of p squared, 2pq, and then q squared. So p squared is going to be dealing with the dominant, or sorry, let's be more specific, homozygous dominant genotype. And this is the key. All of these guys are going to be the genotypes. So heterozygous genotype. And finally, we have the recessive genotype. Now, with this stated, let's check out the first problem. The frequency of the recessive allele, stop. So that tells me I can only pick one or the other. It's going to be either Q or Q squared. And since it says allele here, we know that this is my Q. So again, Q is equal to 0.40. Okay, so that's the variable that Hardy-Weinberg equation is referring to. And like I said, the Y, I see this word there, allele. Now, number 2, the frequency of individuals who express a recessive disease. So when you express a disease, y'all, you are carrying that recessive genotype. So 16%, which variable is this? This is going to be my Q squared variable. This is 16%, okay? And so, or Q squared 0.16 to make it workable. And can we discover the recessive allele frequency? Absolutely. All I have to do is square root that number, and I should get that answer for the recessive allele, or my Q variable. Now, for number 3, it says in a population of rats, 120 out of 350 have curly whiskers and patchy hair. In order for rats to have this phenotype, they must be homozygous dominant for their genotype. So again, this is the key here, y'all. To express it, they must be homozygous. So this number, 120 out of 350, refers to my, you got it right, p squared. Okay, so all of the y's has been described at the very beginning of the video here. So all those variables listed, very crucial that you know it. Let's continue. If 108 out of 300 individuals in a population express the recessive phenotype, okay, which means that they obviously will have the recessive genotype, what percent of the population are heterozygous? So this right here is this variable here, okay? This number represents my Q squared. You got it right. So let's get started and solve this. We have Q squared equals 108 over 300. And now I'm going to use my calculator to get that number. So we have 0.36. So what variables am I missing for my final equation? I'm missing P and I'm missing Q. So there are several ways we can solve this. So I'm going to be taking the square root of my q squared, which means I'm taking the square root of 0.36, and that should get me 0.6. I'm going to use the property that the dominant allele and the recessive allele frequency add up to 1. I plug in my number, okay, and then I solve. So to solve, I simply subtract 0.6 on both sides, and then I should get p equals 0.4. With that said, I have everything I need to get my frequency or percent of heterozygous. I simply plug it in. So my P is 0.4, my Q is 0.6, and then let's type it into the calculator, and we get 0.48, and the problem asks for it in percentage. So 48% are heterozygous. There you have it. Let's work one last one. A population of birds may have red feathers, the dominant phenotype, or orange feathers, the recessive phenotype. The red feather birds have the genotype of capital R, or capital R, lowercase r. Orange feathered birds have the genotype lowercase. The frequency of the boom, and I have a genotype number. So this right here is my homozygous frequency, so it is going to be my p squared. So I'm going to write it to the side here. P squared equals 0.46. Now, it says, what's the frequency of the heterozygous birds? So again, we want to know this here. We need to find P, we need to find Q. And so that's what B and C is asking for. Let's just solve that first. So I have P squared equals 0.46. In order to solve for my P, I simply take the square root, okay, of that number. So let's do that. Square rooting both sides. And once I do that, this cancels out, and I get 0.68. I'm just rounding it here. I'm keeping that number in my calculator. Now to solve for Q, I simply take the equation P plus Q equals 1, and then 0.68 plus Q equals 1. And I'm putting the number into the calculator to get Q equals 0.32. Okay, now I have my frequencies. I can solve for the heterozygous birds. So 2PQ equals 2 times 0.68 times 0.32, and that should get me my number. So we have 0.44 for my frequency. Okay, y'all. If you guys need more practice, it is on Canvas. Have a good one.